Welcome to our YouTube channel. This is Ernest coming to you from MathLab Tutorials in Toronto, Canada. Although seemingly impossible, like many other contributors on YouTube, our mission is to transform some of that destructive hate energy into constructive love energy for a subject that is so deserving. Mathematics is part of all that surrounds us. Just pause for a moment and take a good look. As your screen suggests, like it or not, math really did take us from the Stone Age to the Space Age. The sermon is over, and now let's get down to some serious math. This is video 7 of the video series on radicals, and is just a continuation of video 6. And we'll continue solving simple radical equations. Question 11, solve and verify, and do not forget to verify. We have 3 dot root x equals 2. We can divide both sides by 3. That's optional, but we'll go ahead and do that anyway. We'll get the square root of x is equal to 2 over 3. And now we square both sides. On the left, the square root of x all squared is x. And 2/3 all squared is 2 squared, which is 4, and 3 squared, which is 9. And this will be our solution candidate. The next thing we do is to verify that the left-hand side is equal to the right-hand side. So we go up here and copy-paste the original equation. There it is right there. And we get our solution candidate. There it is right there. And we substitute into the original equation. When we do that, we get 3 dot square root of 4 over 9 equals 2. And then we simplify the left-hand side. We get 3 dot 2 over 3 equals 2. We cancel out the 3's, and you get 2 equals 2. And of course, that's a true statement. And we declare that our solution candidate is in fact the true solution. So x equals 4 over 9. Is indeed the solution. So we'll go on to the next slide. Question 12, solve and verify. Do not forget to verify. On the left, we get 2 root x minus 1 equals 9. The first thing you want to do is transpose that negative 1 over to the right-hand side because you'd like to have the radical by itself on the left. So when you do that, you get 2 root x minus 1. And of course, 9 plus 1 is 10. And then you want to divide both sides by 2 to reduce the equation. When you do that, you get square root x minus 1. And then 10 divided by 2 is 5. And at this stage, you want to square both sides. And when you square both sides, on the left, you get x minus 1. And on the right, 5 squared is 25. And then we transpose the minus 1 over to the right-hand side. And we get x equals 26, and 26 will be the solution candidate. And at the end, we need to verify that the left-hand side is indeed equal to the right-hand side. Again, we copy-paste the original equation down here. We get our solution candidate. There it is right there. We substitute. When we do that, on the left, we get 2 square root 25 because 26 minus 1 is 25, and then minus 1 equals 9. And then we continue to simplify the left-hand side. We get 2 dot 5 minus 1 equals 9. And of course, 2 dot 5 is 10. 10 minus 1 is 9. So we wind up getting 9 equals 9. And that's certainly a true statement. And so we can declare our solution candidate to indeed be the true solution. So we'll go on to the next slide. Question 13, same sort of idea, solve and verify. Do not forget to verify. On the left, we have x minus square root x minus 5 equals. On the right, we have x minus 4. Again, we leave the radical term on the left, transpose the x over to the right. Okay, so on the left, we get minus square root x minus 5. On the right, we have x minus x is 0, and we're left with a minus 4. Then we can divide both sides by negative 1. When we do that, we get the square root of x minus 5 equals 4. Again, we square both sides at this point. When we square the left-hand side, we get x minus 5. When we square the right-hand side, we get 16. And then minus 5 gets transposed over to the right-hand side. And then we get x equals 21 as our solution candidate. So again, we need to verify that the left-hand side is indeed equal to the right-hand side. So we copy-paste the original equation. There it is right there. And we get our solution candidate, which is x equals 21. We substitute into both sides. On the left, we get 21 minus square root 21 minus 5. On the right, we get 21 minus 4. On the left, we get 21 minus 4. On the right, we get 21 minus 4. So that implies that 17 equals 17. Of course, that's a true statement. And we declare our solution candidate up here to be the solution in fact. Okay, next question. Question 14. Solve and verify. Do not forget. This is the first case where we've seen a radical on the left and a radical on the right, which is certainly okay. We need to make sure that we have a single radical on the left and a single radical on the right before we perform an SBS. Okay, and that's certainly what we have. We have a single square root on the left, single square root on the right. It's time to do an SBS. When we do that, on the left-hand side, we get 3x plus 2. On the right-hand side, we get x. And again, we transpose. We get 3x minus x is 2x. And then the 2 comes over to the right-hand side. We get negative 2. Divide both sides by 2 to solve for x. And we get x equals negative 1 as our solution candidate. Again, at the end, we need to verify that the left-hand side is equal to the right-hand side. We copy-paste the original equation, and there it is right there. Then we get our solution candidate and substitute it into the original equation. When we do that, on the left, we get 3 dot negative 1 minus 2, which is negative 1. On the right, we get the square root of negative 1. Notice that the square root of negative 1 is not real, it's imaginary. And the square root of negative 1 on the right-hand side is not real, it's imaginary. Even though the two imaginary numbers are equal to each other, still the equation is not real. And therefore, we conclude that there is no real solution to the original equation. So the original equation has no real solution. Be very careful about that. On to question 15. Solve and verify. Again, do not forget to verify. On the left, we have 2 root x minus 2. On the right, we have 2 root x plus 5 over 2. Because we have a radical on the left and a radical on the right, it's time to square both sides. When we square the left-hand side, we get 3 squared is 9. And of course, the square root of x minus 2 all squared is just x minus 2. And on the right-hand side, we get 2 squared is 4. And the square root of x plus 5 over 2 all squared is x plus 5 over 2. And now we can do like a bullet target over here, or we can expand. On the left, this expands as 9 dot x minus 18. There we go. On the right, this expands as 4x. There it is. And 4 dot 5 over 2. 4 divided by 2 is 2. And 2 times 5 is 10. And we get a 10. And now we can use backward bin gathering, a little bit of backward bin gathering to collect like terms. On the left, we open up an x bin. We drop in a 9. And 4 becomes negative 4. And we hit the equal sign. On the right-hand side, we open up a constant bin. And minus 18 becomes plus 18. And then 10 is just a drop down. So then we simplify each bin as usual. And 9 minus 4 is 5. And 18 plus 10 is 28. At the end, you want to divide both sides by 5. When you do that, you get x equals 28 over 5. And that will be our solution candidate. Finally, we need to verify that the left-hand side is indeed equal to the right-hand side. So we copy-pasted the original radical equation. That was the very first equation that we encountered. And of course, x equals 28 over 5 was the solution candidate. So now at this point, we carefully substitute in to both sides. When we do that, on the left, we get 3 root 28 over 5 minus 2. On the right, we get 2 root 28 over 5 plus 5 over 2. We continue to simplify. On the left, we get 3 root 18 over 5 because 28 minus 10 over 5 is 18 over 5. On the right-hand side, we get 2 root 81 over 10. How did we do that? By cross-multiplying. You get 2 times 28 plus 5 times 5 all over 10. And that'll give you 81 over 10. So on the left, we wind up getting, oh, you know what I did over here? On the left, what did I do? Oh, I know what I did. I decomposed the 18 as 9.2. And then I did the square root of, oh, I know, I pulled a fast one here. 18, I decomposed it as 9.2. And then the square root of 3 is 3. So I did a 3.3, which is 9. There it is. And on the inside, I was left with 2 over 5. And I just multiplied top and bottom by 2 to get 4 over 10. On the right-hand side, this reduces to, let's see how I did the right-hand side. The square root of 81 is 9. So 9.2 is 18. And then we're left with square root 1 over 10. And now, finally, the square root of 4 is 2. So I extracted that. So on the left, I got 9.2 is 18 times square root 1 over 10. And on the right, I have 18 dot square root of 1 over 10. And of course, that can be rewritten as 18 over 10 or 18 over root 10 equals 18 over root 10. And of course, that's a true statement. So we declare the candidate to be a solution in fact. Okay, it turns out that the verification over here was more complicated than the actual solution itself. So there you go. Let's go on to the next slide. Question 16, solve and verify. Do not forget to verify. On the left, we have square root x squared minus 11 equals. On the right, we have 5. Because we have a radical on the left, a non-radical on the right, it's time to square both sides. So if we square the left, we get x squared minus 11. If we square the right-hand side, we get 25. And now it's time to transpose the minus 11 over to the right-hand side. When we do that, we're left with x squared equals 25 plus 11, which is 36. And at this stage, we take the square root of both sides. And when you take the square root of both sides, make sure not to forget the plus or minus on the right-hand side, okay? So when we take the square root of the left-hand side, we get x, and on the right-hand side, this becomes plus or minus the square root of 36, which is plus or minus 6. So that the candidates are negative 6 and 6. So we have 2 solution candidates this time. And the reason why we had 2 was because the argument of the square root up here was in fact quadratic. That's why we wound up getting 2 solution candidates. Now it's time to verify that the left-hand side is equal to the right-hand side. But we have to do that for each solution candidate. So I drew a 2-column t-chart. In the header, I put x equals negative 6. In this header, I put x equals 6. And what I did was I took the radical equation up here. I did a copy paste. I dropped it down here. And again, I took that solution candidate and I put it over here. We're going to sub that into the left-hand side. When we do that, we get minus 6 squared is 36. Then we have minus 11. On the right-hand side, we have 5. So on the left, 36 minus 11 is 25. Then the square root of 25 is 5. And we get that 5 equals 5. That's certainly a true statement. So we have a good candidate. On the right-hand side, let's see what happens. Or, sorry, on the right-hand side of this two-column T-chart, we'll see what happens. Again, we copy-paste the original radical equation. There it is. The solution candidate is right here. We do a substitution. On the left, we get the square root of 36 minus 11. On the right, we get 5. Again, the square root of 36 minus 11 is just the square root of 25, which is 5. So we get 5 equals 5. Again, a true statement. So this solution candidate is also good. And we conclude at the end that the real solution set is negative 6, 6. Again, SS means solution set, and so we get 2 real roots or 2 real solutions. Okay, let's go on to the next slide. Question 17, solve and verify. Do not forget to verify. We have 5 root x on the left-hand side. On the right-hand side, we have 6 minus 3 root x. The whole idea here is to get the radical on the left, okay, and the non-radicals on the right. So we can use a little bit of backward bin gathering to do that. I'm going to open up a root x bin on the left, and I pick up a 5 here, and the minus 3 becomes plus 3. And on the right-hand side, I'm going to open up a constant bin, and I just pick up a 6. Then we simplify inside each bin. 5 plus 3 is 8, and of course on the right-hand side we get 6. We could divide both sides by 8. When we do that, the left-hand side becomes the square root of x, and then 6 divided by 8 is 3 over 4. Now it's time to do an SBS. We're going to square both sides. And on the left, we get x. On the right, 3 squared is 9, and then 4 squared is 16. So we have a single solution candidate. And I'm sure in the next slide we will verify. Again, we verify that the left-hand side is equal to the right-hand side. And what I did was I copy-pasted the original radical equation. Here it is. And then the solution candidate is x equals 9 over 16. As usual, we substitute in x equals 9 over 16 into the original equation. On the left, we get 5 dots, square root of 9 over 16. On the right, we get 6 minus 3 dots, square root 9 over 16. Of course, the square root of 9 over 16 is just 3/4. And on the right, we get 6 minus 3 dot 3/4. So on the left, we get 5 dot 3/4. On the right, we get 6 minus 3 dot 3/4. If we continue simplifying, on the left, we get a 5 dot 3, which is 15 over 4. So we get 15 over 4. On the right, we get 6 minus 4 dot 3 plus 4 dot 3 plus 3. No. What am I doing? Over here, we get minus 9 over 4. There you go. I thought that was an addition over here I thought it was 3 3/4. Anyway, we get a 3 dot 3 over 4, which is 9 over 4. And then we continue to simplify. Of course, on the left, we get a 15 over 4. And on the right, we get 4 dot 6, which is 24. And then minus 9 is 15. So we get a 15 over 4. So on the left, we get 15 over 4. On the right, we get 15 over 4. Of course, this is a true statement. And we declare that our solution candidate, which was 9 over 16, is indeed the solution. Okay, let's go on. Question 18, solve and verify. Again, do not forget the verification. On the left, we get 10 minus 3 root x plus 2. On the right, we get 6 plus root x plus 2. The idea is to make sure that all the radicals are on the left and the non-radical terms are on the right. And we're going to use a little bit of backward bin gathering to do that. I'm going to open up a root x plus 2 bin on the left. So on the left, we pick up negative 3. The 1 in front of the radical becomes negative 1. There it is. On the right-hand side, we open up a constant bin. On the left, 10 becomes negative 10 when you move it over. And on the right, 6 is just a drop down. So then we continue to simplify inside each bin. We get minus 3 minus 1 is minus 4. And then minus 10 plus 6 is minus 4. And of course, at this stage, we divide both sides by negative 4. When we do that, on the left, we get root x plus 2. There it is. And then negative 4 divided by negative 4 is 1. There it is. And it's time to square both sides. When we square the left, we get x plus 2. When we square the right, we get 1. Now we transpose the 1 over to the right-hand side. And finally, we get x equals negative 1 as our solution candidate. And finally, we need to verify that the left-hand side is equal to the right-hand side. So as usual, we copy-paste the original radical equation. We drop it down here. We get our solution candidate. There it is. And we substitute into the left-hand side over here, into both sides in this case. When we do that substitution, on the left, we get 10 minus 3 root minus 1 plus 2. There it is. On the right, we get 6 plus minus 1 plus 2. There it is. If we continue to simplify, on the left, we get a 10 minus 3, and then root 1, because 2 minus 1 is 1. The root 1 is 1, so 3.1 is just 3. So on the left, we get a 10, and then minus 3. On the right, we get 6, and then again, root 1 is just 1, so we get a 1. So on the left, we get 10 minus 3, which is 7. On the right, 6 plus 1 is 7. And voila, this is a true statement. Therefore, we declare the solution candidate, x equals negative 1, as the solution in fact. And let's go on. Question 19, solve and verify. And again, do not forget to verify. On the left, we have square root 2x minus 3 minus the square root of x equals 0. Again, we need to ensure that we have one radical on the left and a single radical on the right. So we're going to transpose this guy over to the right-hand side. When we do that, we get the square root of 2x minus 3 is equal to the square root of x. Because we have a radical on the left and a radical on the right, it's time to square both sides. When you square the left, you get a 2x minus 3. When you square the right, you just get x. We can do a little bit of backward bin gathering here. We open up an x bin, drop in a 2, and then a 1 becomes negative 1. And then we hit the equal sign, open up a constant bin, minus 3 becomes 3. And as usual, we simplify inside each bin. 2 minus 1 is 1, so x dot 1 is just x. And on the right-hand side, we just get 3. And that's our solution candidate. And finally, we need to verify that the left-hand side is indeed equal to the right-hand side. And again, we copy-paste the original equation down here. Here's our solution candidate. And we make the substitution. On the left, we get the square root of 2.3 minus 3. And then minus root 3. On the right, we get 0. So if we continue to simplify, on the left, we get 6 minus 3, which is 3. So we get root 3, and then minus root 3 equals 0. And of course, root 3 minus root 3 is 0. So we get 0 equals 0. And again, we have a true statement. And therefore, our solution candidate is in fact the real solution. So we'll go on, and we'll look at question 20. Solve and verify. Again, do not forget to verify. This time, instead of a square root, we have a cube root. Okay? So again, we have the radical on the left, the non-radical on the right. To remove the cube root, we need to cube both sides. Instead of doing an SBS, squaring both sides for radicals, when we have cube roots, we need to cube both sides. So that's what we're going to do. When we cube the left-hand side, we just get the argument, x minus 1. When we cube the right-hand side, 4 to the power 3 is 64. And again, the minus 1 comes over, and we get x equals 65 as the solution candidate. And at the end, we need to verify that the left-hand side is indeed equal to the right-hand side. We copy-paste the original radical equation. There it is. Our solution candidate is x equals 65. And we substitute into the original equation. On the left, we get cube root 65 minus 1. Of course, on the right, we get 4. 65 minus 1 is 64, is equal to 4. And of course, the cube root of 64 is just 4. So we wind up getting 4 equals 4, which is certainly a true statement. And again, the solution candidate is indeed the true solution. And this is over and out from Ernest. Thanks to all for viewing this video. Stay tuned for many more videos to come. If you liked the video, please give us a like, submit comments, and subscribe to our channel. If not, please tell us how to improve it. Over and out from Ernest at MathLab Tutorials in Toronto.